Hi, welcome to Physics on Table channel. Today I am going to solve a problem that came in TIFR 2018 paper. So read the problem, and if you have a copy and pen near you, you can write the problem. The problem is saying that a small block B of mass m is quickly placed on an inclined plane P, which makes an angle theta with a horizontal chord C, on which P is rigidly fixed. The coefficient of friction between the block and the plane is mu. When the chord stays stationary, the block slides down. If the chord C is moving in horizontal direction with acceleration a, the minimum value of a, that is acceleration, for which the block will remain static is. Four options are given. So this is a problem from pure classical mechanics. So let's solve. So the problem is actually saying that this is a card and there is a block B on this plane P. So, and it's moving with an acceleration a. So what should be the acceleration, the minimum amount of acceleration for which this B block is to be in equilibrium? So we need to balance the forces for which the block B stays at equilibrium. That is, we need to draw free body diagram. Let's do that. It's my request to please write the question paper somewhere, because while I will solve this, you will unable to see the question, or you may take a screenshot of this. So let's solve. This is the plane P. This is the block B. And this is the card C. Obviously, you will get a force mg downward, and this angle is theta. So this angle is also theta, and this is the projection of mg is mg cos theta, and this will be mg sine of theta. Right. Now imagine yourself on this card C. I think you know one thing if you have gone through the chapter centrifugal and centripetal force, that when you are moving in a circle, you are in a non-inertial frame of reference, right? So you will perceive a centrifugal force that is outward. And if you are seeing an object moving in a circle, that is, you are in an inertial frame of reference, you will perceive that a force is bringing that in is bring actually the force tends the object to come at the center. This force is called centripetal force, and this is called centrifugal force. Similarly, you can see that In the question, it is given that the acceleration is in this side, and it is for a person who is seeing this from an inertial frame of reference. If you put that person or yourself, you may imagine, on C, that is in a non-inertial frame of reference, obviously you will see a force is acting in this side, that is towards the right. Now, as this is theta, this angle is also going to be theta. The angle between these two is theta. Similarly, the angle between these two is also theta. Now, let us make projection of this MA. It's MA cosine of theta, and this is MA sine of theta. And this is the normal reaction N. So our free body diagram is completed. Now let us balance the forces and solve for the acceleration. We will get the answer. This N equals to ma sine theta plus mg cosine of theta. That is, N equals to mg sine of theta plus mg cosine of theta. Let this be question number 1. Okay, I forgot one thing. In the question, it is mentioned that the coefficient of friction between the block and the plane is mu. That is, you need to put a force of friction, and as this block is sliding down, that is, in this direction it's moving, the friction will try to balance in the opposite direction. That is, there's a frictional force which is given by mu of N. So for the second one, it is mg sine of theta equals to ma cosine of theta plus mu n. You should pause the video and try the solution of your own. I am doing this for you. Let me multiply mu with equation number 1. As you can see, there is no term involving n in the options, so it's obviously mu n equals to mu ma sine of theta plus mu mg cosine of theta. Let this be question number 3, and this is mg sine of theta equals to ma cosine of theta plus mu n. If you add the two, this mu n and mu n will cancel each other as they are in the opposite direction, so opposite sides. So let me cut this, and it is mg sine of theta equals to mu ma sine of theta plus mu mg cosine of theta, and what is left plus ma cosine of theta. We need to find the acceleration, so let us take common from both the sides. It's mg sine of theta minus mu mg cos of theta equals to mu of ma sine theta plus ma sine of theta. So let me take common mg, mg sine theta minus mu cosine of theta is equal to ma common mu sine of theta plus cos of theta. Now let me take this acceleration, cut m and n, the masses. So the acceleration will be given by g of sine theta minus mu cosine of theta divided by mu sine theta plus cos of theta. You can see not a single option is matching, so you are seeing that there is tangent term in B and C option. So let's see we can convert it or not into tangent. Let's divide numerator and denominator by cosine of theta and we'll get sine by cos tan minus mu divided by mu tan of theta plus 1. Let's see we are getting the answer or not. Yeah, this option is matching, option B. So option B is the correct answer. Hope this is clear to you. Just go through it, try to understand. The question is good, conceptual. You can have a screenshot of it, just see it once. Thanks for watching the video.